So we are starting a new topic today, and this is about application of first law to study flow process. Okay. Now, whatever we have studied so far about the first law, that was applicable to closed system. Now, if you want to apply those equations directly to flow system or open system, it is not possible, right? So because we had started with an assumption that mass is constant. When you talk about open system, the mass is going in as well as coming out. So we have to derive these equations again. Okay. So now how do we go about it is that we convert the flow process to non-flow process. So what we will be doing is, when we'll be solving this, we'll be converting flow process to non-flow process and apply those equations. So how do we do it? Before we go ahead, we have to discuss some terms like what is steady, unsteady, and uniform system. We must be familiar about these words. So steady जो word है, that implies that there is no change with time. Okay, that means if the derivative of properties, you can write it mathematically also. Here, derivative of any property with respect to time is equal to 0. This is called steady state, that things are not changing with time. And phi can be any general parameter. So whatever the parameter is there for any system, if it is steady, then you put any phi. Phi means it can be u, v, w, velocities, pressure, temperatures, anything, density. All those 8 properties of thermodynamic properties, if they remain constant with time, it means it is a steady flow. Okay. Now, there is another word here. Okay. So if you talk about what is the unsteady, then the opposite of the steady is unsteady. Or you can say transient, which means that if you write it mathematically, transient would be del phi by del t is not equal to 0. And here, where phi belongs to, you see, na, for all thermodynamic properties. So here phi is all thermodynamic properties. Here phi is any thermodynamic property. If any one thermodynamic property is changing with the time, then the system is not steady. Is that clear? Then a term comes, what is a uniform system? Uniform means that the variation with respect to space parameters or space coordinates, there is no change. Okay, and if you want to write it mathematically, then you can say del phi by del xi is equal to 0. Or xi, what is xi? Xi is x1, x2 and x3. That is a way of writing it, but this is also equal to x comma y comma z. So if the properties are not changing by changing in x, y and z, then it is called uniform system. And similarly, you will have non-uniform system where del phi by del xi is not equal to 0. Okay, so these are the two categories. We have steady and unsteady flow. We have uniform and non-uniform flow. Right? If you take the example that if in this whole class everybody is wearing same clothes, then we call that everybody is in uniform. Now, today you are wearing blue shirt, tomorrow you may wear red shirt. So it's changing from day to day. तो एक मंडे की ड्रेस है, एक ट्यूसडे की ड्रेस है, एक वेडनेसडे की ड्रेस है, but every dress is called uniform. So when you come tomorrow wearing red shirt, it is also a uniform, but it is not steady. It's changing with time. Okay. And if suppose everybody is wearing a different shirt, but every day he wears the same shirt, then we can say that it's a steady system. And if he's sitting in the same place wearing the same shirt, then with time things are not changing. Then you may call it as a steady system. Okay, so this thing should be clear. Okay, now when we talk about this steady flow energy equation, this is a very wide application. Actually, the real course, this thermodynamics which we are teaching, starts from here. Up till now, whatever was there, you had studied. Only thing it was we had refreshed it and put it in a different way. थोड़ा सा उसको organized way में और थोड़ा सा उसकी details we had discussed in a proper way. But actual thing, you start from here because you have not studied flow system before. Okay. Now you'll find that it is steady flow process which is mostly in use. Because when you talk about closed system and you want to take out some energy or work from it, what will happen? A closed system has a limited amount of energy. So after some time, that system is exhausted. Okay. And you cannot use it further. Suppose you have an overhead tank in your house and close the inlet tap. Okay. And that tank is of no use. Because you can run it for 1 day, 2 days, maybe 3 days. After that, it is lying vacant. Nothing can be made use of it. It's a closed system. Okay, you are not putting anything in. But if you have a tank in which has an inlet as well as outlet, you can use it day after day, day after day. You can continue to use it. Okay. So similarly, if you have any system in which energy is not going in and you are only withdrawing energy, okay, it cannot last long. So you have to input the energy also. But how do you put the energy? There is one thing is that you put the heat and take out the work. That is, you can have a closed system like that. But when the energy is carried by a fluid like air, water, then it has to be open system. Something goes in, some fluid is going in, it is carrying the energy, and the same energy you are using it, and the fluid by after being spent goes out. It is something like that. You can take the example of, let us say you have an IC engine. Okay. So it has two walls here. One is this inlet wall, one is the exhaust wall. What happens is air and fuel goes in and exhaust gases come out. Only then this engine can run continuously for a reasonable duration. Okay. So this becomes an open system. तो इसी तरीके से बहुत सारे और ओपन सिस्टम हैं जो कि मैकेनिकल इंजीनियरिंग में आते हैं, जैसे बॉयलर एंड कंडेंसर. You have nozzles and diffusers. Nozzles and diffusers, they are part of turbines and compressors which are used in thermal power plants. Then you have throttle valves like capillary tube, porous plug, turbines, compressors, reciprocating compressors and reciprocating engines, heat exchangers. All these systems which you will be now studying in future classes, they are flow system. Okay. So that is why this becomes important. Now, the steady flow energy equation in short form is also called SFEE, steady flow energy equation. And let us see what is a steady flow system. What are the properties of a steady flow system? Let me just show first you the system that it is. The system looks like this. There is something going in and something coming out from here. Okay. So it has two openings. One is inlet and one is outlet. Inlet for the fluid to go in, outlet for the spent fluid to come out. Okay. Now let us go about the characteristic. When we say that steady flow system, then no property, intensive or extensive, changes within the control volume with time. That is, we have already discussed what is a steady flow system. No property will change with time. Now then there is a boundary also. Boundary of the system does not change with time. And if the boundary is not changing, no boundary work is done. Unlike a closed system which changes the size. Like if you see these two systems, on the left is open system and these boundaries are rigid boundaries. Okay. So at these boundaries, no work will be done because F into delta X is required. But if you have so work is done here, work can come out from here, the boundary which is moving. Okay. Now, if you have a closed system like this and it changes boundary like this after some time, so this boundary has done the work done by the system on the surrounding. Okay, this is W comes here. Okay, so what will happen here? Because boundary is not changing, no work is done. Now, because it's a steady system, mass of the fluid inside the control volume remains same with the time. The total mass in the system should not change. Okay. And if you apply that, in other words, mass of the fluid entering the system is equal to the mass of the fluid leaving the system. Whatever mass is going in, same amount of mass shall come out. Only then what will happen? The mass inside the system will remain same. And that is why you can say it's a steady system. Then energy of the fluid inside the control volume also remains same. So everything has to remain constant. The energy is also remains constant, which means energy entering the system is equal to the energy leaving the system. Okay. Now then there is something entering in because it's an open system. So when the fluid is entering in the system, properties of the fluids leaving the system, okay. So there is a inflow and there is a outflow. The properties of that should also remain constant. Whatever is entering in, उसकी जो thermodynamic properties हैं and whatever is coming out, उसकी जो thermodynamic properties हैं, they should remain constant with time. ठीक है? Now, how do we actually apply this steady flow energy equation? What we do is we divide the system in three parts. There is a main system, an element of mass which is enters the system, and a element of mass which leaves the main system. So there are, we divide the whole system into three parts. Okay. Now let us come back to the diagram again. Yes. So if you see here, there are three parts. On the left side, it is the beginning of the system at T1. And right side is the state of the system at T2. Okay. Now on the left side, there are two systems. One is this main system given by this boundary, and one is this small system. Okay. Or when you go to the right side, after some time, what has happened is this is the main system and this is the system which has come out from that. Okay. So basically there are three elements. One is the main, which is contained in the vessel. A small portion which is going in, that is the second one. And a small portion which is going out, that is the third part. Okay. So what do we do to apply the first law to steady flow system? We begin with actually unsteady flow. So that equation which I am going to derive first, they will be for unsteady flow. Unsteady flow means that the inside properties are not same, may not be same. Inside mass is not same. Okay. And the mass which is entering in is not equal to the mass which is leaving. Okay. Why we are doing it? Because we have to also study non-steady flow systems. Now, the equation for non-steady flow system, if we apply the conditions of steady flow system, you get the equation for steady flow system. So what we will do, we will start with non-steady flow system, apply the condition of steady flow systems, and we will get equations for both. There is no point studying both of them separately. Okay. तो ये अब हम सिस्टम देखें तो इसमें जो है, अब ये जो है नॉन स्टडी फ्लो सिस्टम, बिकॉज ऑल द प्रॉपर्टीज वी हैव एज्यूम्ड दे आर चेंजिंग. ओके. तो लेफ्ट साइड पे जो आपका मेन ब्लॉक है उसमें टोटल एनर्जी इज रिप्रेजेंटेड बाय जे. ओके. इट इज एट टाइम T1. At time t1, this is the energy. Okay? And this is the mass of the main system. So on the left side you have J1 at T1, on the right side you have J2 and T2. And here you have M1 and you have M2. So what is happening? At T1, the main system is having total energy as J1, mass as M1, and both these are changing. At time T2, your system has mass M2 and total energy as J2. Okay. Again, there is a mass, small mass M1 and small mass M2. M1 is entering the system during this interval, and same mass is leaving the system. Sorry, different mass M2 is leaving the system during time T1 and T2. Okay. So you will find that on the left side you have main system and the mass which will be entering in during this time. So you have two systems. On the right side you have again two systems, the mass main system and the mass which has come out of the main system during this time. Okay. Now then the mass which is entering in has its own properties. Okay, these properties are U1, C1, Z1. U1 is the internal energy, specific internal energy. C1 is the velocity, and Z1 is the height. Okay. Similarly, the mass which is leaving out is U2, C2, and Z2. U2 is the internal energy, C2 is the velocity, and Z2 is the height. Now, if we consider these two systems together, at T1, M plus M1, or sorry, you can have M1 plus M1. At T2, you have system M2 plus M2. Then the system is closed. If you put both these systems together, nothing else other than this, there is nothing else which is going in or coming out. So the initial system is M plus M1, sorry, M1 plus M1, small m1, and at the end of the time, the systems are M2 plus small m2. Okay. So we can, if we take system like this, we can apply the first law equation Q minus W is equal to delta E. So now we are taking at the starting at T1 the main mass and inlet mass as one system. At time T2 the main system and the exit mass as the second system. Okay. Now this this delta E, this is the total energy of the system. It has three components we have already talked about. This is the thermal internal energy, kinetic energy, and potential energy. Okay. So E will be equal to this. We are talking about all the energies. Now there is one more thing, that when you have a closed system, how do you get the work out? There are actually two types of work which are happening here. Okay. So one is called shaft work. So what is happening? The main mass is moving some piston or rotating some shaft, and the work is coming out. So you see this example here. Here this is a shaft work, okay, which is moving to and fro, and by that we are getting some work out, okay. And even here you can have, in this diagram you can have some fan like this which is taking out the shaft work. So something is moving in, it can be turbine, it can be a fan or a rotor, by which you can even give the work in, or by which you can draw the work, okay. Because the boundaries are not moving, so you have to get some work. तो उसके लिए जो है we have this a shaft work. So there is one component is a shaft work done by the system on the surrounding, like work done by a fan, stirrer, electric motor, turbine. This is how that work is either transferred in or transferred out of a. Then there is something called flow work. Now what is the flow work? Flow work is the work done by the system on the surrounding, expelling the fluid out of the system, and negative of the work done by the surrounding on the system in pushing the fluid into the system. So surrounding is doing work on the system by pushing some mass or some fluid into the system. You find that the small mass which was on the left side is actually gone into the main mass. So the surroundings have done some work to push it in. And similarly, the system has done the work on the surrounding by throwing out some fluid. It has to displace the surrounding. So there is a shaft work, sorry, this is a flow work, and the difference between the two you can find out what is the work done by the system on the surrounding as a flow work. Okay, and this flow work is equal to MP2 V2 minus M1 P1 and small v1. Okay, this is P delta V. Work done is, because here we are taking, if you take small volume, specific volume, then you talk about M. So this much of the volume of the surrounding, you can say this much of the volume of the surrounding has been displaced, and there is a pressure. The P is the pressure of the surrounding, and we are assuming that internal and outer external pressures are same. So the work done by the surrounding, in any case, even if they are not same, the external pressure is to be taken. So work done by the system on the surrounding is P2 V2 into M2. And similarly, surrounding is doing work which is equal to M1 V1 and P1, and you can subtract that, you get the total work. So the total work is equal to sum of shaft work and this flow work. Okay. Now you apply the equation. What will be the change in energy of the system? Now remember, your system is made up of two parts. At the beginning, it is containing, sorry, at the end, it is having mass M2 and a small mass M2. These two are together forming the system. In the beginning, you have M1 and M1, which is forming the system. So the in the final energy is J2 plus M2 into total. So J2 is the total energy of the main system, and the remaining thing is the total energy of the mass which has come out. Similarly, initial energy is J1, the total energy of the system, plus the total energy of mass m1 which is entering in. And this has to be equal to Q minus W, because this is a closed system. And so you get the equation Q minus W is equal to J2 plus M2, this minus this. Okay. And it's same thing here. Now what we have done is, this work has two components. One is a shaft work and one is a flow work. So what we have done, the flow work from this has taken on the right side. So this is the flow work. I could have put one more step in between, but you can take it like that. So here the work is made up of two work, shaft work plus flow work. So shaft work remains on the left. We don't have any equation for that. But the flow work, we know the equation. M2 P2 V2 minus M1 P1 V1. And you take it on the right side. And what you get is these two terms on the right side. Now this U2 and P2 V2 is added. This becomes H2. And this U1 plus P1 V1 is added. You get H1. So you get this equation. So this is your equation for non-steady flow. कौन सा W? WS? W is sum of the two. You have to take whole work, na? Heat given minus total work done by the system is equal to change in energy of the system. Okay, we are using the equation for the Q minus W is equal to delta E. That was for a system which is having both microscopic energy and macroscopic energies. So potential and kinetic energies are included in delta E. Okay. Now, if you look at this equation, you can very well apply here the assumptions of the steady flow and you get the equation for non-steady flow. So what are the condition of steady flow? J1 and J2 should be same. Nothing should change inside the main system. The mass which is entering in should be equal to the mass which is leaving. So it is M. Okay. And if you put that condition, your shaft work will be equal to, total work will be equal to shaft work plus M P2 V2 minus P1 V1. Your M2 and M1 are same. So you can put them together. And then your change in energy becomes like this. M into U2 C2 square plus GZ2 minus U1 C1 square GZ1. It becomes, because M1 has equal to M2 and J1 has become equal to J2. So what has happened is, it should be, okay. This J1 and J2, they will cancel out and M1 will be equal to M2. So you will get delta E equal to this. Okay. हाँ, H1 और H2. H1 और H2 इससे आया कि H1 जो है इंथाल्पी का जो डेफिनेशन है, H1 इज इक्वल टू U1 प्लस P1 V1 और H2 इज इक्वल टू U2 प्लस P2 V2. Okay. So again you put this into Q minus WS and you get this equation Q minus the WS is equal to this, and this is the equation for steady flow. Simple. So what change has occurred if you want to compare it with the for the closed system? U has been changed by delta H. If you write for the closed system, it will equal to Q minus W is equal to M delta U. This will be the equation. But because some fluid is going in, so kinetic energy is going in. Because it has a height, mass is going in, it has a height, the potential energy is going in. So change in potential energy, change in kinetic energy, and the flow work when added to this, you get this equation. Right? So what is actually it is equal to, so the total energy of the system has gone. That is not relevant for us. What is the total energy of the main system? Because in the steady flow that remains constant. तो ये जो गया heat given to the system minus work done by the system is equal to m delta h plus half delta c square plus g delta z. Okay. Now, what are the different forms of these equations? Now you can divide both sides of the equation by m. Okay, and you get this equation. Now remember, when it was a closed system, we were dividing by the mass of the system. Here we are not dividing by the mass of the system, but we are dividing the mass which is entering the system. Okay. So this is the amount of energy given to the system, thermal heat energy given to the per unit flow of per unit mass of the mass entering the system, and this is the shaft work per unit mass entering the system. Okay, and this is the, you can say, change in enthalpy, kinetic energy and potential energy of the mass which is entering in and coming out, final minus initial. Okay, if you divide it by time, okay, you get this equation m dot. The mass of the main system is gone, it's not coming in the equation. The total energy of the system is gone, it remains constant. Total mass of the system is gone, it doesn't, of the main system, it doesn't come into the equation. So what you are getting is mass of the mass which is entering the system. So Q dot, and you can even write it like this. M dot can be, if you want to write this above equation, you can have m dot delta T. M dot is the rate of mass entering in. Okay, and so if you put all of them together, these are the equations, and okay, you can write in different forms. Okay. The best way I would say is this, you can remember this, and with this you can develop all other. Okay. M dot delta T is also equal to the mass entering during the time interval delta T. You can write that. You can divide by mass, that mass can get it. Okay. Now, this whole thing can be applied to cyclic process also. Now, what is a cyclic process? In a cyclic process, in which the properties change periodically with time. So what is happening is, if the system is such that the main mass properties are changing with time, but they come back to the same point after the cycle is over. So if we can take such system and apply it for integral number of cycles, then the same equation can be applied. So even though our system is not steady, like your IC engine or a reciprocating compressors, these are they are not steady flow system. IC engine, the main mass is changing, is compression होता है, expansion होता है, burn होता है, फिर उसको बाहर फेंक देते हैं. All that happens. But after the cycle, what is happening? It is at the same state. New mass and same temperature, same pressure, same composition. Same thing happens in the compressor also. You take some air, compress it, throw it out, and then you again take the air in. So again, the system has come back to the same state. So what you can do is, instead of applying the equation, steady flow equation from T1 to T2, which you cannot because the system is not steady, but you can apply it from one cycle to the second cycle, the beginning of the cycle to the beginning of the next cycle. Then the properties are same. Okay, so this also you can apply. So if you have reciprocating compressors on engines, you can apply steady flow energy equation to them, keeping in mind that the 2 points which you are selecting is, one is the beginning of a cycle, first cycle, and the second point is the beginning of the second cycle. Between that you can apply the equation. Okay, equation is complete, and I will stop here because then there will be no time for attendance. After this, what we are going to do, once you know this equation, then we will take up all those systems, like we have boilers and condensers, nozzle, diffuser, turbine and compressors, throttling processes, reciprocating compressors, mixing chambers. All these we can take and apply this steady flow equation on them and get some special equation for a boiler or a nozzle, or you can say diffuser, etc. We'll be doing that, but that all you can do it yourself. The only thing is, the equation which I gave you for the steady flow, that is that encompasses all processes. All steady flow processes can be solved by that. But then what we do, there are certain special assumptions for each process. Like for boiler, you take the flow work as 0. You assume it to be 0. It cannot be. Why it cannot be 0? Because you have to put something in and something will come out. It's a flow system. So some work is done. But what happens is, people say in the engineering, you can say industry, that the change in the boiler, the amount of energy given is so high, thermal energy, the work is very insignificant part of it. So let us forget about it and write an equation for it. So the equations become very simple, still more simple than what we have, but with assumptions. So now it's up to you. You want to apply equation for boiler after the assumptions or before the assumptions. So you can do one thing, you can remember the main equation and know the assumptions what are there in the boiler, or whether you want to apply those assumptions or not. If you want to apply those assumptions, the equation will be still modified. So instead of remembering equation for each process, you remember what are the conditions for each process, apply that and you get the equation for that immediately. That is a better process. Okay, instead of remembering 10 equations and finding ye isme ye lagega, isme ye lagega, isme ye lagega, but you know why in boiler you take work done as 0, why in nozzle you are not talking about this काइनेटिक एनर्जी तो आता है, उसमें वो नहीं आता, थर्मल एनर्जी नहीं आता, नोजल में थर्मल एनर्जी नहीं लेते हम लोग. तो दैट यू कैन remember once for all and you can do it. So we will